Good morning, everyone. My name is Rich Lusick, and this is the Unit 6 presentation for Environmental Sciences at University of the People. Here's a quick roadmap of what we'll cover today across four major themes. First, climate change. I'll be grounding this locally in my home region of Ontario before zooming out to the global picture, and we'll look at both causes and solutions that are already underway. Second, air pollution. We're going to look at two pollutants that are directly relevant to my hometown area and affect people in the province of Ontario: fine particulate matter, or PM 2.5, and ground level ozone. Third, we're going to examine waste management. We're going to evaluate what Ontario is doing well and where there's room to improve. Fourth, we're going to tackle two climate change myths that genuinely distort public understanding and policy, and we're going to connect that to one of the greatest environmental success stories in history: the protection of the ozone layer. Before we talk about the impacts and solutions, it's worth grounding ourselves in the science, because understanding the mechanism matters for understanding why climate change is happening, at the rate it's happening, and why it is different from natural cycles. The greenhouse effect itself is a natural and essential process. Without it, Earth's average surface temperature would be around negative 18 degrees Celsius, far too cold for life as we know it. Greenhouse gases like carbon dioxide, methane, and nitrous oxide trap outgoing heat radiation from Earth's surface, keeping the planet warm. The problem, as Harris explains in Chapter 10, is the dramatic increase in the concentration of these gases due to human activities, primarily the burning of fossil fuels and deforestation. Since pre-industrial times, atmospheric CO2 has risen from roughly 280 parts per million to over 420 parts per million, a level not seen in at least 800,000 years of ice core records. If you look at the three statistics on the left, global temperatures have risen 1.1 degrees Celsius above pre-industrial averages. CO2 concentrations hit a new record in 2024, and sea levels are rising at 3.6 millimeters per year, faster than at any point in recorded history. These are not predictions, they are measurements, and they tell a clear story. So what does this actually look like in practice? Well, let's start close to my home. I live in an area of Ontario called Simcoe County, and climate change is already visible here. Although we still get a lot of snow, as I am in an area known as the Snow Belt, our winters are measurably warmer, and the ice season on Georgian Bay is shorter every decade. In 2023, wildfire smoke from northern Ontario and Quebec blanketed southern Ontario for weeks, triggering air quality advisories from Environment Canada. We're also seeing intensified rainfall events and flooding in the Great Lakes Basin, and heat waves are becoming more frequent and more severe, posing health risks to elderly populations and outdoor workers in the region. The United Nations 2025 climate report highlight accelerating sea level rise that threatens to displace hundreds of millions of people in low-lying coastal nations. We're seeing more powerful hurricanes, more prolonged droughts in food-producing regions, ocean acidification destroying coral reef systems, and accelerating ice loss in the Arctic that feeds back into further warming. The key message here is that climate change is not a distant future problem. It's present, local, and intensifying reality, both in my home region and around the world. The good news is solutions do exist at every level. Locally, Ontario has made real investments in green energy, including solar incentive programs and the protection of the Greenbelt, which is a land area over 2 million acres, environmentally sensitive land that acts as a carbon sink and buffers against urban sprawl. At the national level, Canada has implemented a federal carbon pricing system. Although controversial in some circles, viewed as simply a tax, the basis of the federal carbon pricing system is to put a price on emissions to incentivize businesses and individuals to reduce their carbon footprint. Canada has also committed to net zero emissions by 2050. Globally, the Paris Agreement remains the cornerstone of international climate action, setting a target to limit warming to 1.5 degrees Celsius above pre-industrial levels. The European Environment Agency notes that the EU Green Deal is pushing Europe toward carbon neutrality by 2050, with massive investments in renewable energy and emerging carbon capture and storage technologies. Now let's turn to air pollution specifically. I've chosen two pollutants that are highly relevant to Ontario: The first is fine particulate matter, known as PM 2.5. PM 2.5 refers to particles that are 2.5 micrometers or smaller in diameter. To give you a sense of scale, a human hair is about 70 micrometers wide, so these particles are roughly 30 times smaller than that. They are invisible to the naked eye. What makes PM 2.5 so dangerous, as Herrick explains in Chapter 10, is that these particles are small enough to bypass the body's normal respiratory defenses, the nose hair, mucous membranes, and cilia that filter larger particles. PM 2.5 particles penetrate deep into the lungs, and the smallest fractions can actually cross into the bloodstream. In Ontario, our main PM 2.5 sources are wildfire smoke, which was catastrophic in 2023, vehicle exhaust, industrial emissions, and agricultural burning. Southern Ontario has some of Canada's highest traffic density, meaning urban residents face chronic low-level exposure year-round. The health consequences are serious: aggravated asthma, COPD, elevated risk of cardiovascular events, and reduced lung function over time. PM 2.5 is also an ecosystem stressor. It contributes to acid deposition that acidifies soils and waterways, harming aquatic ecosystems across the Canadian Shield. The second air pollutant we're going to look at is ground level ozone. Unlike PM 2.5, which is directly emitted from combustion sources, ground level ozone is what we call secondary pollutant. It is not emitted directly by any source. Instead, it forms through a chemical reaction. Nitrogen oxides from vehicle exhaust and industrial stacks react with volatile organic compounds in the presence of sunlight. This is why ozone levels are highest on hot, sunny summer days. This matters for policy. You can't simply regulate an ozone smokestack because there isn't one. You have to regulate the precursor emissions, and that requires a more complex, multi-sector approach. For human health, ground level ozone is a respiratory irritant. It causes chest tightness, shortness of breath, and lung inflammation. It disproportionately affects children, the elderly, and people with pre-existing respiratory conditions. Waste management may seem like a slightly separate topic from climate change and air pollution, but they are deeply interconnected. When organic waste goes to landfill instead of being composted, it decomposes anaerobically and releases methane, a greenhouse gas approximately 80 times more potent than CO2 over a 20-year time frame. When materials like aluminum, glass, and paper are thrown away instead of recycled, we must extract new raw materials, a process that consumes enormous amounts of energy and generates significant emissions. The EPA's 2025 guidance on recycling makes a compelling case. Recycling conserves natural resources, reduces energy use, decreases pollution from extraction and manufacturing, and supports local economies through job creation in the recycling and waste diversion sector. But Abu Bakr and colleagues in 2022 added a critical equity dimension. In the global south, where the majority of the world's population lives, waste is still predominantly managed through open dumping and uncontrolled incineration. This releases toxic chemicals, heavy metals, and particulates that disproportionately harm marginalized communities, often the same communities that have contributed the least to global waste generation. The waste hierarchy at the bottom of the slide reflects the priority order. First, we need to reduce how much waste we generate. Second, reuse what we can. Third, recycle. Fourth, recover energy from waste. And only as a last resort, dispose. Ontario has a reasonably strong foundation in taking steps to improve our situation. The Blue Blocks program is one of the oldest and most recognizable curbside recycling programs in North America. The Green Bin composting program in many municipalities diverts organic waste from landfill. And Ontario has a household hazardous waste drop-off site program across many regions for materials like batteries, paint, and electronics that should not go to a landfill. Ontario has also moved towards extended producer responsibility, shifting costs and logistical responsibilities of recycling packaging back onto producers who create them. This is a major shift, designed to incentivize companies to make products that are easier to recycle in the first place. Climate change myths are not just harmless misconceptions. They have real-world consequences for policy, public funding, and collective action. Let's take a look at two of the most persistent ones. Myth 1. Climate change is just a natural cycle and humans aren't responsible. This is probably the most common dismissal of climate science. While it's true Earth's climate has varied naturally over millions of years, there is a distinct difference because of human impact. Ice core records going back 800,000 years show CO2 concentrations never exceeded 300 parts per million, yet now we've crossed 420 parts per million in a matter of decades. That rate of change has no natural analog. The policy impact of this myth is severe. It's been used for decades to justify blocking emissions regulations and withdrawing from international climate agreements. Myth number 2: climate change only affects distant places. It's not my problem. We've already addressed this on the impact slide, but it's worth naming explicitly as a myth because the sense of distance is a genuine barrier to action. When people imagine climate change as something happening to polar bears or Pacific Islands, it doesn't generate the urgency needed for local and national policy changes. The 2023 wildfire smoke events affecting my area of Ontario are a vivid example. The policy consequences of this myth is community-level complacency, reduced investment in local adaptation infrastructure like flood barriers, urban heat island mitigation, and air quality monitoring. Now, there are success stories. Let's take a look at the ozone layer. The stratospheric ozone layer sits between 15 and 35 kilometers above Earth's surface. It absorbs between 97 and 99% of the sun's harmful ultra B and C radiation. Without it, we would see catastrophic increases in skin cancer rates, cataracts, immune suppression, and damage to marine ecosystems, since UV radiation penetrates water and harms phytoplankton, which form the base of the ocean's food chain. In the 70s and 80s, scientists discovered that chlorofluorocarbons, or CFCs, used in refrigerants, aerosols, and foam packaging were destroying ozone molecules in the stratosphere. The Antarctic ozone hole was the alarm bell. In 1987, the Montreal Protocol was signed, the first global environmental treaty to achieve universal ratification by all 197 UN member states. Here's the climate dimension that the UNEP highlighted in their 2025 analysis. Many ozone-depleting substances are also extraordinarily potent greenhouse gases, in some cases 1,000 to 10,000 times more warming than CO2 over a 100-year period. The 2016 Kigali Amendment extended the protocol to include hydrofluorocarbons, HFCs, which replace CFCs but are themselves powerful GHGs. The ozone layer is now on track to fully recover by the middle of this century. That is what global coordinated action looks like when it is committed to. So let's bring this all together. We've examined 4 environmental challenges that are deeply interconnected: air pollution, poor waste management, climate myths, and the ozone layer success story, which shows us what's possible when we do decide to act. There are 4 takeaways I want to leave you with. 1. Climate change is not theoretical. It is scientifically confirmed and actively reshaping life all over the world, and in my home area of Ontario. 2. The air we breathe in Ontario is affected by PM 2.5 and ground level ozone, both of which can carry serious health consequences that our healthcare system is already struggling to manage. 3. Sustainable waste management is not just an environmental nicety, it is a necessary part of reducing greenhouse gas emissions. 4. The Montreal Protocol proves evidence-based science, communicated effectively and acted on globally, can reverse environmental damage. It gives us reason for genuine optimism. Robert Swan said, "The greatest threat to our planet is the belief that someone else will save it." There are solutions available. The question is whether we choose to use them. The following slides contain the resources used to generate this presentation.